Hi guys. So in this series, I'm going to basically record what I'm doing while learning simple linear regression with Python. So for this, I'm going to use Anaconda's Jupyter Lab. So I've already launched it, and this is how it looks. So I've created a new notebook here, and I'm going to rename this as simple linear regression. So as I said, I'm going to be using Python. So I'm using Python 2 here, and so for doing any regression problem, we need some data set. So I'm going to use Kaggle's data set here. I'm going to get some data sets from Kaggle. So the idea here is to see the whole process of how I'm doing anything and what kind of resources I'm using. So you guys can also learn and try to do this for different problems that you guys are interested in. So I'm going to filter it by linear regression. Sorry. And a CSV type. So this looks like a beginner level data set. So I'll be downloading this. So I think you can download it from here by clicking this. I've already done that and I have put it in my basically the folder which I'm going to use. Now Python has a very popular package which people who are data scientists generally use, which is called pandas, to basically to load data into data frame. So I'm going to use that as well. So let's start writing the code. Import pandas as pd, and now we load the data, basically the salary.csv, into a data frame called salary. So here is the syntax for doing that. Read csv and salary.csv. Okay, so since we are in the same folder as the file, I don't have to specify the entire path. So let's see how the data looks. So the good thing about Jupyter Notebook is that you can just simply type the data frame and it will print out what the data is. You don't have to write print and then put the data frame inside that as you would do in a normal Python console. Okay, so there are about 34 records in this data frame. So it has years of experience and the salary. I think they are trying to see how salary depends on whether there is a relationship between the salary and the years of experience a candidate has. So maybe let's try to plot this into a graph and see what it shows. So for that I'm going to use matplotlib, which is a popular library for you, which is used for plotting any graphs or whatever, like charts in Python. So here we use the scatter plot, which I think makes sense since this is just having two variables. So I think so. Another tip and trick, since we are on Jupyter Notebook, all you can do is press Shift Tab, and it will show you the function's definition. So I think we need to know what is x and y and pass that as the first two parameters. So in our case, let's put years of experience in x-axis and the salary itself in the y-axis. Try to plot it. Cool. So this is what we are getting here. I mean, there are ways where we can label these x and y axis. I'm not getting into those details right now for this video. So this looks like there is some linear relationship between the years of experience, which is on the x-axis, and the salary on the y-axis. So I think this data set is a good candidate for doing a linear regression. So I think now we can see how to implement a linear regression model to fit into this data, and then probably we should try to do some prediction also. Okay, so for linear regression, I think there are ready-made algorithms. These are pretty standard algorithms, and Python already has packages which have implemented these algorithms. So we'll probably use scikit-learn for basically building our model. So here it is. So we can generally like just see, they'll have some examples. The documentation is pretty good for scikit. So this is what I'm using. So let's see how to build our model. So I've already, so if you don't have scikit-learn installed on your Jupyter lab or notebook, please do that. So I've already done mine, so I can simply import this. So this is what I'm going to do. So linear model has been imported. Next, let's see how are they implementing the model. So I think we'll have to create this object and fit our x and y into this. So before I do this, I think generally in machine learning, what data scientists generally do is whatever data set they have, they will try to split it into test and train. Uh, Basically, they'll partition their data set into two sets. One would be test and one would be train. Generally, they'll take like 70% of the data to train their model, and then they'll test their model on like the rest of the 30% of the data. So again, to split our data set into train and test, we can use another module which is part of scikit-learn itself, which is called train test split. Let me show you that as well. So scikit, I don't remember all the syntax, that's the issue. So train test split. So like I said, I'm also learning, so please bear with me. So I think it's part of model selection in scikit-learn, so we should try to import this as well in our Jupyter note. From scikit-learn, sorry, import train test. So the easy thing here is that you can just start typing something and like press the tab key, and it would basically show you all the options and help you to autofill it. So this is done. So let's see what train test split would take as input. So like I said, you can press shift and tab to see the this documentation of the function. So let's see, they have shown how they are using this train test split. You can pass x, y, the test size. Here they are using 7367 as the split. So let me just copy this. Okay, I think these things are not necessary. So in our case, x is basically the years of experience. Sorry, years of experience, and y is the salary. Salary. Let me make this 30.3. Cool. So let's try to see what's the shape of this X train. So there are, so basically for training, out of, so we saw there were 34 records, so we are going to use 24 of these records for training. And for X test, there are 11 records, right? Okay, so actually it started from 0, so there are 35 records. So now that we have X test, X train, Y train, we have split up our data set, let's try to use the regression model for, basically let's try to build our model first. So like we saw in the tutorial in documentation of scikit-learn, we have to create an object of linear regression class and try to fit it. So let's see this. So here we don't have x and y, we have x train and y train. Okay. Oh, I'm getting an error. So got 1D array. Okay, so there is an error. Let's see what the error says. It says reshape your data either using array if your data has a single feature. Yeah, so like we saw here, we have only one feature, which is the years of experience. So let's try to um, follow what the error says. So I think we need to create a numpy array out of xtrain. Let's see what is xtrain. If it's already numpy array, then we don't need to do anything. So it's a series type, so we need to create a numpy array. So let's try to do that. Okay, so I think first we need to import the numpy package. So let's create the array and reshape it with what was presented in the error message. Okay, now let's feed this into the model. Oh nice, now it works. So let's see what's the next step. The next step is to check the score. So let's try that as well. I think for us it's not x and y, it's okay, cool. It says 97.55. I think it's not perfect, but that's what we expect, right? Now we need to check how to use this model to predict. So I think we need to look at more examples. Let's look at a linear regression example. Here they are using a different data set, the diabetes data set. So we have done till the fit part. So now I think we should use this predict. So they also have, I think, like an X test, Y test, the training test split. They are predicting the data using X test. So I think we have to follow the same thing. For us, we'll have to predict X test. So again, X test, we'll have to fit it into the numpy array. That would be array okay. So now let's predict y dot predict. We just have to pass X test array. Nice. So let's see what the values are. Okay, so it looks like somewhat like the salary field that we were seeing here. So I think now we have to check how to find the accuracy of the model. So what are they doing here after predicting? Okay, yeah, so like you know, in linear regression, the idea is to minimize the squared sum of the squared errors, right? So let's see what is the mean squared error for this model. Okay, let me just copy this syntax. So did they import something? Yeah, I think we have to import this metric. So we're not going to do R2 square right now. Let's try mean squared error first. So in our case, ypred is ypred and ytest is ytest. Okay, so this is our mean squared error. So that's it for the linear regression. We can say that our model is 97.55% accurate and with the mean squared error of whatever this value is. It's a huge number. I don't want to read that out. So I'll try to put this up in a GitHub and link it to the description. But I think this is pretty clear, I believe. So that's it for today. I'll try to do the same thing for some other examples as well, and maybe not take simple linear regression and take maybe multiple linear regression next time. Thank you.